So this question says the function f of t equals 40,000 times 2 to the t over 790 power gives the number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? All right, from a strategic standpoint, anytime I see a variable in the exponent, I'm always curious as to what I get when that variable is equal to 0. Now, in this case, t is our variable. T represents time in minutes after the population, after initial observation of the population. So if I put t as 0 here, then 0 divided by 790 is 0, and I'd end up with 40,000 times 2 to the 0 power. But anything to the 0 power is just equal to 1, right? So 2 to the 0 power is just 1. So really what I'd have here is 40,000. And that tells me that the bacterial population 0 minutes after an initial observation, or better yet, the initial bacteria population was 40,000. So I'm just trying to figure out, well, how long does it take to get to 80,000? Right? That's the question. How long? What does t equal in order for us to get to 80,000 as a population, right? Which would be doubling. So looking again at the math that I have, well, I have this 40,000, and I already have times 2 here, which would give me 80,000. I have, again, this t over 790, but I'm going to think about the fact that if I could just have 40,000 times 2, I would get to 80,000. So what does t need to be so that I can maintain this 40,000 times 2? Well, overall, this exponent should be 1, because if the exponent equaled 1, then I just have 40,000 times 2 to the first power, which is 80,000. So what can t equal to make that fraction of t divided by 790 equal to 1? Well, t would equal 790, right? Because if t were 790, then we'd have 790 divided by 790, of course, with 2 to that power. And of course, 790 divided by 790 is just 1, which gets us exactly to where we'd like to be here. So that's our answer, right? That's the t value. 790 is the t value that would lead us to figuring out where, or at what time, I should say, the number of minutes beyond the initial observation where our bacterial population is 80,000. And all of that opened up for me because I first figured out what the initial population was by setting t equal to 0, which then lets me know what a doubled population should be, which then allows me to figure out what t is in order to make that true. So 790 is our best answer here.